So we have to find the value of square root of 13, and since 13 is a prime number, then there is no simpler form for its square root, and square root of 13 is an irrational number somewhere between square root of 9 and square root of 16, which is basically between 3 and 4. Therefore, a reasonable first approximation would be that square root of 13 is near 3.6, which is the same thing as 18 over 5. But we can get a better approximation from our initial one. Let's call it A0. And we're going to use Newton-Raphson method. So formula for this is A sub I plus 1 equals A sub I squared plus n over 2ai. But it's more convenient to separate ai into numerator pi and denominator qi, and therefore we're going to use formula p sub I plus 1 equals pi squared plus nqi squared, and q sub I plus 1 equals 2p times q. So in our case, n is equal to 13, then p0 is 18, and q sub 0 is 5. So now I'm gonna substitute our values into our formula, and we get that p1 equals p0 squared plus 13q0 squared, and that's going to be 18 squared plus 13 times 5 squared, therefore we get 649. For q first, we get 2 times p0 q0, and that's going to be 2 times 18 times 5, and therefore we get 180. So if we stop here, our approximation would be square root of 13 is near 649 over 180, which is 3.605. So we're gonna do one more iteration. So that's gonna be p second equals p first squared plus 13q first squared, and that's gonna be 649 squared plus 13 times 180 squared, which gives us 842,401. So Q2, that's 2P1 Q1, and that equals 233,640. So now our approximation is that square root of 13 is near 842,401 over 233,640, which gives us 3.60555127547. So that's the value of square root of 13.